I do beg your pardon. I'm going to have to go back to slide one. I do beg your pardon. Good morning, good afternoon, good evening, good wherever you are. And apologies for the slightly hickey start to this presentation. I appear to have forgotten to press the start button, which is most unlike me. I'm normally pressing it well in advance of when we should start. So anyway, just to make sure you're on the right presentation, today is a cloud storage technologies presentation from SNEA. And our topic today is continuous delivery, cloud software development on speed. So who are we? I am Alex McDonald. I'm your moderator today, and I'm an independent consultant and chair of the SNEA Cloud Storage Technologies Initiative that are bringing you this presentation. And I'm joined today by Davis Frank. Good morning, Davis. How are you?
I am well, Alex. How are you doing today?
I'm fine, thank you. Davis has been in software engineering for nearly 30 years. And as I mentioned the first time before failing to press the start button, you can actually get a much shorter prison sentence for murder than that. He's worked in early desktop videos at Intel, video games at Broderbund, mobile computing at Handspring and Palm, and web development at Pivotal. Well, at Pivotal, he consulted with dozens of companies around continuous delivery practices and wrote the JavaScript testing framework Jasmine. So we're in good hands today, and we have a true expert in the field with us. Thank you very much for coming along and doing this for us, Davis.
I'm looking forward to sharing.
So what's it about SNEA? Well, we're 180 industry-leading organizations representing the storage networking industry. We've got around 2,300 active contributing members, which is a good number. And also a large number of people like yourselves, IT end users and storage pros worldwide, who number about 50,000. You can learn more about what we do as an organization at snea.org/technical. And you can follow us on Twitter, if that's your thing, at @SNEA. What do the CSTI do in particular? Well, we've got four main goals in life. The first is to educate. We're trying to educate on cloud storage, data services, orchestration, and a wide range of technologies associated with cloud storage and cloud technologies. We support and promote business models and architectures. We've done work in the past on OpenStack, software-defined storage, Kubernetes, object storage, a wide range of topics to do with this particular cloud area. We're in the business of trying to understand your requirements and hyperscaler requirements and incorporating them into standards and programs, and then collaborating with other industry associations that give us a wide reach across not just storage, but also other parts of technology infrastructure. So just a quick legal notice, the usual piece. I'm going to boil this down because neither Davis nor I are lawyers. There are no warranties in this, express or implied. Use at your own risk. If whatever you do with it causes whatever you're doing it to break into two parts, both of them are yours. This is a presentation of SNEA, and we do actually claim the copyright to it. So I would strongly recommend that you adhere to the copyright indicators given in this particular slide. We are, however, as I said earlier, not lawyers, we're technicians. Hurrah! Much simpler life. So the agenda today, we're going to talk a little about what is continuous delivery and why our product teams are adopting it in particular. We're going to talk a little about software development as a manufacturing line, how to implement your team, and how to get started. And while we're doing that, I would strongly recommend if you go up and look, you can ask questions on this interface. And if you wish to ask a question, do so. And I will make sure that Davis gets to answer it for you live on the presentation today. If we fail to answer it live, we'll take it forward to our blog, and I'll give you the address of that as we terminate the presentation at the back end. But in the meanwhile, Davis, what is continuous delivery? It's all yours.
Thank you so much. So to talk about continuous delivery, like I said, I've been helping teams adapt and adopt these practices for a while, is to think often as the metaphor of the assembly line, which we all know came about in the audio industry. And roughly stated, right, you imagine some kind of giant manufacturing warehouse where car parts come in on one side. There's a bunch of repetitive tasks in the middle that we don't necessarily need to understand. And out of the back of that same warehouse come cars and ideally profit. Profit is why capitalism exists, right? And this worked really well. It scaled for a long time, adopted across the world, and scaled as the car culture took off. And we talk a lot in the U.S. about what happened. A good example of what happened at the sort of end of that scale with General Motors, where things didn't necessarily go well. Some 50 to 60 years on, where car parts still came into the warehouse on one side, and a bunch of repetitive tasks happened in the middle. But there were wind up a lot of situations with parking lots full of cars that needed rework. Buick bumpers on Chevrolets and Oldsmobile hubcaps and trim on Pontiacs. Regular labor issues as they tried to optimize and fix some of these problems. And cars eventually did come off the line. And there was sometimes profit, but so as it scaled, there were problems. Is really the takeaway here. So, what does this have to do with software? Well, if we're going to extend this metaphor and play with it a bit, requirements come into one side of your team, your development team or teams, and a bunch of tasks that maybe you don't necessarily understand happen in the middle. And what's supposed to come out the other side is working software, and again, ideally, profit. And this worked well for not unlike manufacturing. Automobile manufacturing worked reasonably well with this idea of a waterfall process where things gradually got more and more refined. Everything was designed up front. Requirements come in, software comes out. But much like the auto industry and the auto assembly lines, the waterfall doesn't always work, and certainly hasn't worked over time with scale. The results were things like missed deadlines, bugs and regression, feature sets missed, maybe some working software, and often some reasonably working software. And we'll leave profit for a different webcast.
Davis, before you go on to this next slide, this one about regressions always fascinates me. How do regressions get? I mean, regressions are where you made a bug fix, to version A, and you got A dash, which is the bug fix version, and for some reason in version B, the bug fix gets missed. How does that happen? I mean, there were defined process when I was a boy. There were defined processes for preventing this kind of stuff from happening.
Sure. So we'll go with the definition of regression, right? It's something a bug happened, you think you fixed it, and it comes back. I don't think there's really one answer to that, but I think broadly stated, and this I think applies to automobiles as well, is basically these systems that we're building over the years, largely because of customer demand and business context demand. Things get much more complicated, right? Think about what's in a car today versus what was in a car 20, 25 years ago, right? We've gone through being excited about having a cassette deck in a car, and now there's no way to get any audio to the car except via Bluetooth and that old thing, what's it called, radio, right? That's just one example. The amount of software that's running on cars as well. So basically, I like to. I'm hand waving a little bit, but I think it has a lot to do with the complexity and interactions with more systems over time means that something that you thought you fixed comes back because of complexity. Usually, some dependency or maybe some piece of software that you're using. It was working one way, and you wrote software to fix a bug to work around that bug, and it comes back because somebody, like the dependency, fixes their bug, and now you've worked around it in a way that causes the problem to show back up. But there are many ways that can happen.
But pretty common from what I can gather.
Yes, happens quite a lot.
Okay, thank you.
Sure. So waterfall projects, right? Sometimes even it can be even worse, right? Where you think you've built something really robust. Oops, sorry. Now I'm trying to go to the next slide. And maybe at the top things look reasonable, but you're not necessarily built on the best foundation. Oops, and this doesn't bode well for your software in the long term. So if software in automobile manufacturing or just manufacturing in general have scaled and had similar problems, let's look back at manufacturing and how did they solve these problems. Well, there's an idea that came about called lean manufacturing. Came out of US research, but famously applied in Japan post-World War II, most notably with Toyota. And this was things along the lines of just-in-time purchasing of materials, keeping inventory low, only building products as soon as possible from knowing that you're going to be able to sell it, so you weren't keeping inventory of completed products. There was a lot of sharing expertise among teams within the warehouse. Workstations were broken into smaller and smaller pieces so that less complicated things could get evaluated together. And on cords, which if you're not familiar is the idea of anybody in the manufacturing line could pull a cord and stop the line because something's not working. This, preventing many faulty products from coming out of the back of the line. They could fix it earlier. And of course, increase automation because robots can replace humans in some places here. And of course, that's going to increase quality and speed things up in some situations. So I like to think that continuous delivery is lean manufacturing for manufacturing of software. It's just the simplest way to apply or a translation, I guess, of these things, right? And so continuous delivery really means shipping and shipping and shipping and shipping. And that's shipping incrementally, which is, the idea of instead of doing a big bang release with tens or hundreds of new features, that you're shipping new software with smaller and smaller feature sets. Finishing that feature set, getting it out, finishing that feature set, getting it out, which then sort of coexists with shipping more frequently, right? Getting away from this idea of a big bang release every, 2 years or 18 months and moving to frequencies as often as monthly or weekly. And I can tell you that there are definitely some things that a lot of us are using very regularly where new features are being released daily and you just don't even know it as an end user. And doing this safely, and by safely, I mean in a way that is not risking your business and not risking your customer experience. And thinking about all these things together is what continuous delivery is all about.
Given the nature of the picture you're showing there, safely.
Well, right, exactly. I will say, and as I've said before, as we were preparing this webcast, if you do a search for shipping in the Creative Commons database, the Ever Given does show up very quickly. And as soon as it shows up, I said I had to include it in some way, shape, or form in this presentation. And I would say let's think less about this particular shipping vehicle and really think about the idea of a container ship with a lot of small containers on it, moving frequently. And let's go with that.
Yeah, it actually brings us to a question. There is a serious question at the back of this. Someone in the audience is saying, does the lean methodology work well in terms of delivering software, or is it still too heavy a process for rapid development by software engineering teams?
Oh, that's a great question. I've got some slides coming up where I'm going to adapt it a bit, and I hope to answer that by the end.
Okay, good.
So I hope the audience will bear with me on that one.
Yep, that'd be good. Thank you.
Great, thanks. And so why can we do this? So this is all about the cloud, and right, that's why we're here. The rise of big data centers and everywhere, and software moving online, right? What software what software don't we use anymore that isn't delivered via the cloud? Whether it's web application like this software that we're all sharing this information in today, or with our phones, or just anything in the browser, right? The fact that the cloud exists has made a lot of things I'm about to talk about now very, very possible in ways that were not when we had to put disks on shipping containers and send them around the world. So how do we get into this? And this is getting into answering the question that was asked. So how do we adapt some of these, or what are the analogs? Maybe is a better way to think about it, of lean manufacturing, and how they apply to software. Well, this is just a subset, but I think it's the early ones worth talking about. It first is incremental planning, shortening feedback loops, continuous integration, frequent team rotation, and automated testing. And I'll go into details about all of these. So incremental planning, this is roughly analogous to the just-in-time, some of the just-in-time aspects of lean manufacturing. And the idea here is that your planning is a funnel, and the further away you are from actually implementing functionality or having your development team actually write code, the less detailed your planning needs to be. So, and this allows for flexibility, right? You're not spending a lot of time doing a crap ton of planning for something you might not get to for a year or 18 months. Or even if there's something that you were thinking that you might do in a couple of months, but by the time you actually get ready to get started on that, your business context has changed. A competitor has released something that you need to respond to, or new technology exists and you want to jump on that, or your customers have told you what they want. You can just hand wave around the high level roadmaps and things, and maybe even rough planning, more detail for like the release that you're working on. And really your team is doing very detailed planning for this week and the next week. And this allows for that much flexibility. You haven't invested a lot in design and planning ahead of time, and that allows you to spend your money on the thing that you're working on closer proximity right now. Shortening feedback loops, I'm a big fan of this. We're talking about designing and estimating for the shorter horizons, right? But that also means getting the feedback into the team, or into the company even, very quickly as while you're doing work and after you've shipped things. So one of the things to do here is to definitely keep the work in progress low on teams. Definitely means keeping people on one team at a time, not splitting, spreading one person across multiple sub projects. You might think that you're getting expertise and moving each of those projects forward a little bit faster, but you're probably slowing down everything, which is not in the wrong kind of slowing down. Not slowing down to go smooth, but slowing down to reduce delivery, and allowing or encouraging people to only working on one story at a time. Like multitasking is a bit of a myth, so work on one team and really only work on one thing at a time instead of multitasking across things. Another thing is to keep working software around all the time. That means, especially with web applications, having some sort of there's a term we use, either staging or acceptance, deployment or environment. Basically, the latest code should be running somewhere ahead of, earlier than in its life cycle in production, so that people in the company can be playing with it, whether it's your developers validating something they can't validate locally, an acceptance or a QA team, or even the product team. And by that I mean some kind of product manager who's accepting and rejecting work, and that means then that product person can be, or people can be accepting and rejecting functionality as often as daily, if not faster, so that teams know, like, oh, yep, that's what we agreed to do. It's working, fantastic. Let's move to the next thing. So keeping those feedback loops short is essential. Automated testing. This is one of those things that, much like picking up, giant robot arms picking up big pieces of steel and aluminum for cars, having testing frameworks and having an automated test suite is huge. Whether you're doing TDD, test-driven development, which I'm a big fan, or you just have a very robust feature and unit and maybe acceptance testing systems, having these test suites, having them very easy for developers to run locally on their workstations, to verify that they A, that things are working, and B, they haven't broken anything. And this is to catch regressions, Alex, as you mentioned. And then also, and keeping them fast so that people run them frequently. And then also easy to run externally from developers, whether it's in a continuous integration system or a QA effort of some kind. But having that those test suites exist and exercising the product as completely as possible. And this also means if you find a bug, write a test, get that test to pass so that it's green, and run it forever. And that's another thing to protect against those regressions. And automated testing is very tightly coupled with continuous integration, because CI is all about testing all the things again, right? Running your test suite or suites on every code check-in, right? If the developers think they're done, they've checked in that code, pull the code down into a container or another deployment or within the test frameworks and run them again. And any of the code, when that code change passes, get it onto your staging environment. And if it doesn't pass, don't put it to that staging environment. And if there's a failure like that, the team should be jumping on it and fixing that thing first. That becomes the highest priority. So this is our and-done cord, right? This is like preventing problems from ever getting to production. This is why it's important if the current version is always usable, because you'll find things early. And what's also interesting is that doing building the scripts and things and the automation around this and getting these test suites running, it's great for practicing and building up the tooling for making deploying to production easy. Team rotation. This might not seem that obvious, but Linus Torvalds was famous for saying, given enough eyeballs, all bugs are shallow. And I think this is really true. Outside perspectives from other teams and other people on your team, you can uncover issues. You can spot alternate implementations. You can get diversity of thought and ideas, which is great. This is why a lot of teams have some relative, some practice of code review more and more these days. I'm a strong advocate of just rotating people around with teams. This helps across interfaces between teams that work together as well, because you do that even more in real time than some asynchronous code review process. But this has a lot of other interesting things, not just speeding things up and sharing information and making, in general, your product and your code better. It starts to encourage a shared ownership of code, which is great because this reduces your points of failure. And what do I mean by that? Well, people can have lives. They can pick up their kids from school. They can go on vacation once we all start doing that again. What happens when you have a single point of failure, one expert and a tech on your team or a part of the code on your team, and what happens if they get recruited to go work at a competitor or just another company, or they decide to retire? You've suddenly exposed a lot of business risk. So spreading information around on your team by rotating people around is a great, especially with the developers, is a great practice to help mitigate all those risks. And there's a great side effect, which is it turns your teams into a third way to apply the factory model here, just a factory of learning where people are learning all the time. And this is great for keeping people interested and motivated about their jobs and staying with your team longer. If they're always learning new things and can help out more and more, then they're more likely to stick around and provide that perspective later. Yes, sir.
Firstly, an observation. I used to work with a terrible manager who used to say, you'll get informed by me on a need-to-know basis, and you don't need to know, which I always found very, very difficult to live with when I was doing development. But I've got a question here from the audience. How well do software engineers, in your experience, adapt to moving? As you move engineers to new areas of the code, do you experience that they spend time rewriting what's not broken because they didn't write it in the first place? I suppose this is the NIMBY thing. Not in my backyard. You're continually critiquing and rewriting other people's code. Do you find that an issue?
It can be. There's some ways to mitigate. There are a few ways to mitigate that risk. One is concerted sharing of information. The most radical of this, a lot of people think, but I'm also an advocate, but I wasn't going to bring it up because it can get a little controversial, is I'm a big advocate of pair programming, where you have two developers working together on any problem. And among the things that prevents is exactly what you're talking about. It's like, I don't understand this, so I'm going to rewrite it. I think that can be problematic, or it is a risk. And things like pairing can mitigate that. I think another thing that mitigates it is really good test coverage, because it's expensive to rewrite code. It's less expensive to read about how it's actually supposed to work, and correlate the two, and try to figure out something. The other thing I'll add is that sometimes the software that you don't understand is the software that you wrote days, weeks, or months ago. And I talk a lot about this in some of the other talks I've given, where you're the worst developer that or the worst code that you've ever read is often code that you yourself wrote some number of months ago, and you don't remember writing it, but your source control will tell you that you were the culprit. And so I think spreading information around the team, where you can just say, how's this supposed to work again, and why did we make this choice, and looking at your source control for good comments, and looking at your test suites to say, oh right, that's why this exists. And remember, that's the it's your tests wind up designing for providing you information in the future, for future self. So actually, well-designed test suites can actually help with this as well.
Okay, thank you.
Sure. And sort of a meta thing here I like to talk about is that the most effective teams and the most effective CD teams out there are ones where the team admits that the process, that is how they actually build their product, is as much of a product as the software that they're building. This is, lean comes back to constant tweaking and experimenting and optimizing and learning, and keeping this feedback loop short. Teams need to do this themselves, about how they're working, and holding regular retrospectives where you're talking about, hey, looking at, what is the team's feelings? What have we learned this week or this release? And what can we fix for next time, and help, put work in, prioritize work to make something smoother. I think it's super important. These are their team they're the closest to how things get done. And if you listen to them, they can tell you how they can work better. So retros are really important, and honing their craft. And again, this backs to constant learning, and creates a lot of loyalty on teams, and keeps morale high, and gets more product out the door with higher quality. And I wanted to also touch on one other meta thing, which is to acknowledge the fact that, and this is, Alex, this is where some of that complexity comes in that we talked about with regressions, is that a lot of the problems, as more and more software is getting written, we're sharing software, whether it's through open source or through other solutions. And a lot of the problems that we wind up having are they're software problems, in that, not problems with software, but problems that you can solve with other software, right? Whether it's a test framework, or many test frameworks. If you're in a lot of the web development these days is, a multi-language domain. Platforms as a service to make deployment super, super easy for developers. The whole DevOps world came out of applying software to consistent configuration of servers. SRE, system reliability engineering, a lot of good practices that most famously were documented out of Google, but this is a whole another role out there where there are a lot of people writing good software for keeping monitoring and keeping the health of their systems up and going all the time. There are SaaS solutions for continuous integration. They seem to pop up all the time, and each one is better than the last. This is a way that you don't have to write some of that automation control yourself. And I think something that probably touches a lot with the crowd here today, is that all the cloud services that exist, and storage was one of the first ones that was, I recall being just amazed when cloud storage started showing up, services started showing up for us. And while those are very famously on the public cloud, those public cloud infrastructures from the big providers are coming into private clouds, and just about every shop that we talked to at Pivotal had some hybridization between public and private cloud systems, and using those to accelerate two things really. All of these things here both accelerate your development and get you into the cloud and get your cloud software faster, but you're also relying on these dependencies, which are moving fast as well, which means that more work is done by other people and other teams and other products, which means you can really focus on your business value versus, the undifferentiated heavy lifting of platform as a service or a database in the cloud or something like that. So use your software; it will help you. So how do you really get started? Well, I'm going to leave you with a bunch of homework. Some of my favorite books on these topics, the Phoenix Project, which is really a great argument for DevOps on the server side, but it does talk a lot about manufacturing line and software control of manufacturing line. So it's right up the alley what we're talking about today. Lean Startup, maybe this helps with the original question, but Lean Startup, Eric Ries's book does a great job of talking about using Lean to validate your business models basically, and running experiments to the point of doing all the stuff in that incremental planning so that when you get to software, you're likely spending money on the right things and on building the right things based on good information. I like to mention my friend Elizabeth Hendrickson's book called Explore It, which is about exploratory testing, which is in a world of automated, I get this a lot, in a world of automated testing, what do I do with my QA team? And exploratory QA is the answer. Great book explaining those principles. Mm-hmm. And I come from the extreme programming or XP world side of the agile software continuum or universe. And XP Explained is still a great book for talking about having great relationships between product and development teams. I have a couple of blog posts. One's called The Continuous Delivery Test, which is aping the Joel test from nearly 20 years ago now, or 10 plus years ago, of about the health of your software team as it pertains to some more detailed things around CD that I've mentioned today. Just a bunch of questions to ask your team and how to get better at it, get better at CD ideas. And then I wrote a specific post about this process as product idea. So those are a little self-promotion, but I think that those back up and give you some more detail over some of the things I mentioned today. And if you're curious about NUMMI, which was GM's joint venture with Toyota in the 80s and 90s, about how GM tried to get into lean manufacturing, there's a great episode. There are actually two, but this one is the one with updates about the NUMMI effort that was in Fremont, California, here in the Bay Area where I am. And while Chevy and Toyota did not build cars anymore there, that's where Tesla builds all of its cars in the US. And with that, I say, I wish you all happy, sweet manufacturing lines.
Thank you. Krispy Kreme has even made it across here, the pond.
Fantastic.
Yeah, we can buy Krispy Kremes by the dozen.
Yeah, it's a good thing and a bad thing.
Yeah. So thanks very much, Davis. I've got a lot of questions. I just want to take a deviation slightly. We were going to be joined in this presentation by Glyn Bowden of HPE, who was going to talk about some of the user experiences of doing continuous development that he's come across. But unfortunately, Glyn's wife fell seriously ill, and I'm sure he won't mind me saying this, but she's been on the road to recovery for a little bit, and we wish her well. He told me earlier that she is making progress, which is really nice. But that's why Glyn couldn't be with us here today. Unfortunately, his wife was seriously ill. So, but I've still got questions for you. So there's a few from the audience. You answered, I think, okay, the one about the lean methodology. Well done doing that. Some really good ones. Let me give you one. Do you still see a need for product release timeline? or does this moving software, or does this move software completely to a place where a feature is enabled as soon as it's ready? And how do you cover feature regression? Because feature regression is a bit, I suppose, like any other kind of bug regression. You might actually regress a feature out of your product while you're actually moving that fast. How do you avoid that kind of thing?
Wow, there's a lot there. So I would say let's talk about the product release idea first. I think there are a couple of different views here. I think from an end user view, depending on the type of software, there's value in having the concept of a release that has new functionality, whether it's release notes or commitments to shareholders. There's definitely there's some value in having some sense of what that timeline is and sharing that information, even if it's changing, even if it's changing some. But I think when you get down into the team, a highly functioning continuous delivery team is just kind of always working. And I think this is why the manufacturing line idea metaphor kind of works, right? Is that the teams that I've been on that have been the happiest, or the ones that I've observed from the outside are happiest, they literally are taking in requests for work, and they're just taking the next thing off the top of the backlog, and members of the team are working on it, and then shipping it out into the world. So you got the sense of momentum, right? It's not quite it's not about whether it's Lucille Ball shoving candies in her mouth at the end of the manufacturing line, or good grief, we don't want Krispy Kremes falling on the floor. But the idea, just as a software engineer, you come in the morning, it's like, oh, what's the next thing? What am I supposed to be working on today? Pull the card off, whether it's a Kanban board or whatever tool you use, and just working on that, and just kind of working all the time. And the product release from your perspective as a member of that team is, you almost don't think about whether something is live or not. Yes, you should celebrate it when it happens, but it's almost you can get to a point where the development team, it's just so smooth. The development team is just kind of always working and happily working, and features are getting to production, sort of automatically behind the scenes, and the team doesn't really think about it that much. And that's a great way to be. It's not something you can start doing tomorrow, but teams can get there, and I think it's super helpful.
What about the consumers? What about the end consumer of the product you're developing? Are they happy having this? I often sometimes think I'm a Chrome user most of the time, and I sometimes get slightly frustrated when features can keep popping in and out of existence on a fairly regular basis. Do the end users get a say in this in terms of the delivery model?
Sure, I think. I think you bring up a good example of you want to do it in such a way that it doesn't confuse the user, right? Like, do we actually think, if you think about Amazon, right? Amazon's updating all the time, and you can make arguments about whether we like Amazon or not as a company, or even what their UX is like, but they are updating it frequently, and so often that we don't even know it, right? So do I really know? I go to Amazon to buy shampoo, or to competitive price electronics or something, right? I don't necessarily care about how that software is delivered. I don't even think about it. But maybe on something like Chrome, or personal finance software, when things are working a certain way, I think it's best, and this is more of a product concern than a development concern, like that you should take users on a journey to give them better functionality, whether that means developing a whole new suite of functionality and sort of migrating people there, and giving them something better that's more productive. But that's where you get into user interviews and making sure you're solving real user problems versus just cranking features out willy-nilly, right? I think there's nuance to those things.
Yeah, and Twitter, I'm looking at you. The other one I wanted to bring up was just a final one, which was Zuckerberg's famous quote that I think is misrepresented, but it was pretty famous at the time: "Move fast and break things."
Mm-hmm.
And I'm presuming that move fast and break things is an internal process. It's not one that gets to the outside world. It's somewhere in this lean process. There's a way of being able to move fast and break things, but also deliver robust and reliable product at the back end. I mean, if you've got a team that's out there, moving fast and breaking things, great. But what are you actually getting delivered at the end of the day?
Right. That was kind of the direction I was gonna answer it in. Is that there's breaking things, there's moving fast and breaking things, but to ship, you better be increasing business value. And broken things don't tend to increase business value, which gets to the safe. When you go Google around for continuous delivery, they always talk about safely, right?
Mm-hmm.
So, I think I think of it more as, try a thing, see if it works, and if it works, great. But if it doesn't, then you've learned something. And this is what lean experimentation is all about, as well. And I think that can happen again at all levels of the planning cycle and all levels of the development cycle.
Mm-hmm.
But if you use the software that you have to make the shipping easy, or increasing the confidence in the product all the time, then the user should never see the broken things. And I think ideally, your product person should never see the broken things, and your QA people and your execs should never see the broken things either, right? This is all about and shareholders, right? It's like the breaking is to learn.
Mm-hmm.
And things like testing and CI and some of the other things that I mentioned in here today should be increasing the confidence that that broken things never make it out of the warehouse.
Yeah, it's a process of exploration rather than destruction, I think is what you're saying.
Yeah, exactly.
Yeah. Well, Davis, thank you very much today for your presentation. This has been fascinating. I've learned quite a lot today, actually. And it's also taken me back to my days sadly, as a developer. And as somebody noted in the question and answer session, they said, when you were a boy, was dirt young too? Yeah, it was actually. So thanks for viewing this webcast. And just to remind you, this webcast will be available in our educational library. All the links that Davis presented will be active as well. You'll be able to click through those links into the relevant websites and places that we've pointed you at today on this webcast. We're going to do a Q&A as well. We'll take some of the more interesting questions and the ones we didn't answer, because we did have quite a few, and add them to our SNEA Cloud blog, which you'll find at sneacloud.com. I mentioned the @SNEA handle that you could follow on Twitter. There's also @SNEA Cloud, which is our own personal Twitter handle. On your way out today, I would be immensely grateful if you would rate this presentation. Where, one is, gosh, I wish I'd been doing something else, all the way up to 5, which is more of this. Thoroughly enjoyed it. It really helps us as well if you add commentary to your scoring, because that allows us to go back and review what we did and make sure that we're presenting you with information that you're finding useful, interesting, and just generally doing the right thing when it comes to these educational Bright Talks that we do here at SNEA.
Because you want to keep your feedback loop short, right, Alex?
We want to keep our feedback loop pretty short indeed. Exactly. And hopefully we're not going to run around and break things. We're going to move fast, but not break things, I think, from our perspective. But anyway, thank you very much today. Thank you for your presence. And I do hope that this finds you well. Take care. Thank you very much indeed. Thanks, Davis. Bye now.